Hi, everybody. It's Miss Curran, and I thought I would make you a video of how to do scientific notation and sig figs. A lot of you guys were absent when we went over that, and it's kind of complicated. So the worksheet that we're doing is this one here. Hopefully that, look, I see a backward image. I don't know if you guys are going to see it backwards or not. But you see we have scientific notation at the top, and then we have significant figures on the bottom here. And then the back of this sheet has rules for how you do significant figures. Okay. There will be quite a few questions on scientific notation and significant figures on your test next week. So that's why I'm going over this. I'm going to do about half of these problems, and then you can finish the worksheet following the instructions I just gave you on how to do this. So let's go ahead and start with scientific notation. Okay, so we've got 4 examples here. And scientific notation is used to get rid of a bunch of digits. If you have a number that's a really long, big number, or if you have one that's a really small number with like a decimal and a lot of digits, you can make it easier to write by using scientific notation. And basically what you do is you're going to put it in this format right here. A dot B, so that could be like 2.5, it could be 1.7. It just has to be one digit and the decimal, and then you can have more than one digit afterward, and then times 10 to the whatever the exponent is. That just tells you how many places it is away from the decimal. When you use scientific notation format, notice it says only one digit to the left of the decimal. So if you had a number, and I'm just going to draw it on here, if you had something like 27.2 times 10 to the third. See how there's 2 digits to the left of the decimal? This is not proper scientific notation. You would have to change it by moving the decimal over so that you only had 1 digit to the left of the decimal. I'll show you that when we do a couple of these problems. Okay. So let's go ahead and do number 1. So number 1, right now the decimal is right here at the end. And we want to move the decimal so there's how many digits? 1 digit to the left of the decimal. So how many places is that? 1, 2, 3. So we would write 1.000. That's this number with the decimal moved 3 places. And then times 10. And how many places did we go back? We went back 3, so you 10 to the third. Notice that it's 10 to the third because we went to the left 3 places. If you had to go to the right 3 places, it would be 10 to the negative third. That's how you know the difference. Number 3 is like that, as a matter of fact. You guys, if you look at number 3, see how the decimal's way over here? And we've got to get this decimal point over so that it's in between the 3 and the 7. And that way we'll have just 1 digit to the left of the decimal. So how many places is that? 1, 2. So we would go 3.75. So that's this number with the decimal moved over 2 places. So there it is. Times 10, and we move the decimal 2 places to the right this time. So that's to the negative second. Okay. And then you go ahead and do these 2 as examples. So this one's going to be like that one, and this one's going to be like that one. Okay. Numbers 5 through 8 are the reverse of what we just did up here. So for these, they're already in scientific notation, and you're going to change them back to standard notation. So we're going to get rid of the 10 to the whatever and just write out all the places. So let's go ahead and do number 5. So this one's 5.02 times 10 to the third. So 10 to the third is the same thing as 1,000. We're taking this number and we're timesing it by 1,000. This number is going to get bigger, right? Which way is the decimal going to go? If you've got the decimal here at 5.02 and you want this number to get bigger because you're going to times it by 10 to the third, isn't it going to go to the right? Yes, it is. So how many places? 3 places, because this is 10 to the third. So you would take the decimal, you go 1, 2, and then you need another 0 because you don't have any more digits. So you'd put another 0 after the 2. So you would get 5020. And that is this number times 10 to the third. Okay. You'll notice that number 6 and number 7 both have negative decimals. So they're a little bit trickier. I'm going to go ahead and do this one. That's going to leave you guys this long one with 10 to the negative 10. Guys, when you do this one, write your zeros really small because you're going to have to put like 9 zeros, okay? So write really small in this space. So I'm going to do number 7. So 6.51 times 10 to the negative 2. So again, I'm going to move the decimal, and you can tell I'm going to move it 2 places because this is negative 2. But because it's a negative, instead of moving the decimal to the right like I did for this one, I'm going to move the decimal to the left. And won't that make this number smaller because this is a negative? Right. So I'm going to go 2 places to the left. So if I do that, it's going to be 1, and then I need another 0, don't I? Because there's not another digit. So I'm going to go ahead and put 0, 6, 5, 1. So you can see if the original decimal was here between the 6 and the 5, and we went 2 places to the left, 1, 2. Okay, you get this number. That 0 right there is just a placeholder in the ones place because there's no number there. Okay, so you guys go ahead and do 6 and 8 like we just did those two. Okay, the next 4 are multiplication and division problems. Okay, so now I'm trying to make it so you guys can see pretty well. There's a zoom thing, but I think we're good. So you notice that the first 2 are multiplication, and then the second 2 are division. See those slashes? That's division. Okay, I'm going to do one of each one so you can see how to do them, and you'll do the other one. Notice also that there's 2 places for answers here. See how there's a place for an answer, and then there's an equal sign, and then there's a place for another answer? Some of these multiplication and division problems, when we do them, the answer is not going to be in regular scientific notation format. Do you remember I told you up at the top of the paper, it said you can only have 1 digit to the left? Sometimes when you multiply these numbers or divide, you're going to get 2 digits or more to the left. And you're going to have to rewrite them by moving the decimal over to where it's supposed to be. And that's why there's 2 spaces here. So what you would do is you'd write your answer. All right, I can get this. Oh, it's perfect. Okay, wait. I never move my webcam, so... Right, so see, you'd write your answer with the wrong decimal here first, and then this is where you'd write the final answer in this space over here, where you move the decimal. And I'm going to show you what I'm talking about. Right now, what I'm saying is a little confusing, but let me show you an example. So actually, the first one doesn't have an example of that. The first one, when we do this operation, we won't need to write a second answer. I'm going to go ahead and put a line through there because you don't need to write anything there. So when you have multiplication with scientific notation, there's several steps that you take. When you multiply, I'm just going to write this on the paper so you can see it. You multiply the coefficients first, and then you add the exponents. So let's do that and see what that looks like. Okay, so what are the coefficients? Well, if you look at these 2 numbers right here, see how you have a number and then times 10 to the 4th? So this part here is the exponent, and I'm sorry, this part here is the coefficient, and this part's the exponent. The coefficient, the exponent. So what we're going to do is we're going to take the 2 coefficients and multiply them by each other. So I've got my calculator here on my cell phone, which I have to unplug it. Okay. So our numbers are 1.05. I don't know if you guys can see that. There's 1.05 right there. Okay. So 1.05 times 7.2. Okay. And when you do that, you get 7.56. So we're going to write that number here in the space. I should have left a little bit more space. 7.56. Okay. Now, are we done? No, because all we did was the coefficient part. We did the 2 coefficients. We multiplied them, but you can't just drop these 10s off of here because these stand for a lot of digits. You know, 10 to the 4th is 4 more zeros on the end of this number. You can't just leave it off. So what you do with your exponents is you add them. So this one's 10 to the 4th, and this one's 10 to the 3rd. So 4 plus 3 is 7. So you're going to go times 10 to the 7th. Okay? Now, notice that I said you don't have to do anything to this one, and that's why we put this line here. Guys, if you see how it's 7.56 times 10 to the 7th, you see how there's just 1 digit to the left of the decimal? This one's already in scientific notation format. We don't have to do anything to it. When you do number 10, guys, and you multiply these 2 numbers, you're going to get a number that's larger, and you will have to move the decimal on that one, okay? All right, let's go ahead and do one of the 2 at the bottom. And we need an example where you have to move the decimal, and I'm pretty sure number 11 is one where you have to move the decimal, so we'll do number 11. Okay, by the way, if depending which version of the worksheet you got, I have a typo that I made down here. For number 12, do you see how it says 8.25 times 10 minus 6? That's supposed to be to the negative 6. That's supposed to be an exponent right there. So go ahead and fix that if you got the bad worksheet. The newer worksheets, I fixed it. Okay, same thing over here. This is 3.74 times 10. It's not times 102. It's times 10 to the second. So put that little 2 up there as an exponent, okay? Okay. By the way, this is another one where you're not going to need this extra space, so you can go ahead and cross that out. So it's going to be these two we're going to need to do the extra thing. So I'm now going to show you what that is in number 11. So for number 11, we've got, this time you see the slash in the middle, guys, this is division, okay? So we're going to divide. When you divide, in scientific notation, you divide the coefficients. So before we multiplied the coefficients, this time we're gonna divide them, and then you subtract the exponents. So it's just the opposite. Subtract the exponents. Okay. So let's do it. Okay. So we're going to take our two numbers. 7.2 is our first coefficient, and our next one's 9.4. So 7.2 divided by 9.4. 7, let me see if you guys can see what I'm doing. 0.2 divided by 9.4. And when you do that, you get 0.7659. So 0.7659574468. It's a bunch of numbers. Okay. And actually, we don't really have room to write all that. I'm going to get rid of a bunch of that. You guys don't need all that. We're going to end up rounding this. So I'm just going to put, let's put the 9 on there. I guess it's okay to put the 5/9 part. Okay. And then we've got to do our exponents next. So times 10 to the, now what do you do with the exponents? You subtract the exponents. So 4 minus negative 11. I'm just going to write that over here so you can see it. 4 minus negative 11. Okay, guys? Isn't that the same as 4 plus 11? Yes, it is. When you have a minus and negative, it's plus. So 4 plus 11, 15. So your exponent's going to be 15. Okay? Now, you did your coefficients, you divided them, and you subtracted your exponents, and you got that. But you're not done, because you see this? See how you have a 0 to the left of the exponent? You're not allowed to do that. You have to have a number to the left of the exponent. So we're going to move this decimal. We got to move it one place to the right. So we're going to rewrite this number by moving the decimal. So we're going to go over here, 7.659 times 10 to the, now we have to change the exponent. When you move a decimal, you can't just move it. You have to move the decimal. You're saying that you're either multiplying by 10 or dividing by 10, depending on how many spaces you moved it. We moved this one space. So we either divided by 10 or we multiplied by 10. Well, what does that mean for you when you're trying to solve this problem? It means you look at your exponent that you got, and we either have to take away one of those or put an extra one in there. So how do you know which one it is? Because it's really confusing. The way I do it, guys, is look at this number here. See how this number is a small number? It's less than 1. 0.7659. And then I have all these 10s in here. I have 15 10s, 15 zeros, right? So if I want to make this number become this number, isn't this number over here on the right just this number times 10? Didn't I just move the decimal one place to the right and made it a bigger number? Now I just times it by 10, right? So that means I took one of the 10s out of this 10 to the 15, and I used it to multiply this number. I took one of the 10s. So if I took 1 away from 15, what do I have? 14. So this right here is the correct answer. Okay, this is not the correct answer. If you put this answer on the test, and it'll be on there, guys, I'll put answers like that as like a fake answer, because it's like you're missing the step where you have to actually move the decimal. So just remember that you can only have one, you have to have one digit to the left. So don't do that. Make sure you put it in the final form, and that's why we're doing this worksheet. So if we take it back down there, this is the correct format. Again, because up at the top of the page, that rule said you had to have one digit to the left. So we moved it over one place to the right. We took away one of our numbers from there. Okay? Okay. So you guys are going to do number 10 and number 12. 10 is multiplication, 12 is division. Okay? You're going to do the same process. So that's the end of the significant figures section. Now we're going, I'm sorry, the scientific notation section, which was this part. Now we're going to do the significant figures. I can make it fit. Sure I can. All right. So for the significant figures, we have to know the rules for doing sig figs. So I'm going to flip the paper over so you guys can see the rules, upside down and backwards. So the main rule is that if you have a number between 1 and 9, it always counts as a significant number. So it doesn't matter where it is in the number, it counts as a significant number. The example they gave you here is 129. That has 3 significant figures because it has 3 numbers. Okay. But rule number 2 says if you have zeros in between numbers, they're significant also. A lot of times, the number 1 rule you need to know about sig figs, zeros usually are not significant. Okay, zeros are like placeholders, but sometimes they count. So the real thing you're going to learn by looking at these rules is when do the zeros count and when do the zeros not count. Okay, so that's what we're talking about. So back to number 2. Okay, it says zeros between significant digits are always significant. And the example, 5,007. So you've got a 5 and then 2 zeros and a 7. The 5 and the 7 are significant because they're numbers. These 2 zeros, because they're in between 2 digits, they are also significant. So you have a total of 1, 2, 3, 4 significant digits. Okay, or significant figures. I keep saying significant digits because that's why I was taught in high school and I still remember it. Same thing, guys. Number 3, tailing zeros, that is zeros at the end of a number, are significant only if the number has a decimal point. So I give you 2 examples here. If you look at this one right here, it's 100.0. Because they put that decimal and a 0 after it, this 0 is significant. What they're basically telling you, when they give you a number like this, instead of just, why didn't they just write 100 for this one? Isn't it the same thing? Guys, it's not actually the same thing. If they write 100 and then they write 100.0, one of those numbers, they're telling you we measured out to the 10th place and there was nothing there, and that's why we put a 0 there. So that's not exactly the same as 100. I mean, it's basically the same, but it's not exactly the same. And in science, it's not the same. So let's look at that again. So you've got your 1, 2, 3, 4 digits. So that counts, these zeros all count as significant. Okay. But now look, here's regular 100. There's no decimal. I mean, guys, we know there's a decimal here, but you notice we didn't write it. So we're looking at this number and we're going, okay, well, these zeros are after, so they're what we call tailing zeros. And there's no decimal, so they do not count as significant. So the only one that's significant is that 1 right there. So this number has 1 significant figure. Okay. Here we have another rule about zeros. This is rule number 4. Zeros at the beginning of a number whose only function is to place the decimal point are not significant. In other words, if you have a decimal and there's zeros at the beginning of it, this is what we're talking about now. So let's look at this example here, 0.0025. So we've got the 0 in front of the decimal. And by the way, that one never counts. It's never significant. The one before the decimal that's by itself never counts. Okay, you got that? Okay. But then look at the other ones. You've got these 2 in between. See, because the decimal's there and then there's 2 in between. So you're like, oh, well, those count because they're in between. Yeah, but there's not another regular, there's not a significant digit over here. If you had a 1 here and then you had those, you could count them. But you don't. You just have all zeros. So these 2 are the significant digits. These ones are just placeholders. What these zeros right here are doing is telling you that this 2 is in the, let's see, tenths, 100ths, 1,000ths. It's telling you that the 2 is in the 1,000ths place. If you didn't have those zeros, like if you had the 2 over here, it would be in the 10th place, and that's a completely different number. So you have to have those zeros as placeholders. They're just telling you where the decimal point is, and that's why they're not significant. So only the 2 and the 5 are significant, and that's why the answer for this one is 2. Okay? And then finally, number 5, the last one of the main rules. Zeros following a decimal significant figure are significant. So if they come after a significant figure, not if they're just after the decimal, but they have to be after a number that's after the decimal. So look at this example. You have 0.000470. So you notice these zeros over here are before these significant digits. You can see the 4 and the 7 are significant, right? These ones are before it, so they don't count. But this 0 here at the end does count because it comes after the sig figs. And again, guys, so the answer for this one is 1, 2. You have 3 significant figures. Okay. And again, I'm just going to point out, because it's at the end, it's like what I told you before with the 100.0. If they have all those digits after the decimal, and they go one more digit past your numbers, and they put a 0 there, they're telling you, we measured out to that place. We actually took a measurement, and it went out to that place. Now, there was nothing there, so we put a 0 there. But we measured that far. So that number is significant because it matters, because we did measure to that place. That's really what that means. Let's look at the other example now for number 5, for rule number 5. So guys, look at this one. See, you have 0.47, and then you have 3 digits after the 47. So the 0 before does not count. But all of these zeros after the 0.47, they count because they're to the right of the decimal, and they come after significant numbers. So this one has 5. 1, 2, 3, 4, 5 significant digits. Okay. So I went over that so you'd understand what we're going to do on the other side. And there's also rules about when you add and subtract significant digits and when you're multiplying and dividing. There's rules about that too. So we'll get to that when we get to those problems. So I'm going to go back to the other side now. So now we're here on significant figures. And so there's 8 examples here for you to do. And what it says is using the chart on the back. So we just reviewed the chart, so now you know all the rules. Determine the number of sig figs in each of the following. Okay, so if you look at this first one, there's a 0 before the decimal, and then there's a decimal, and then there's a 0 after the decimal, and then there's a 2. So if you remember the rules, zeros before a significant figure are not significant. So how many sig figs do you have here? 1. That number 2 is your significant figure. The other ones are to the left, so they don't count. Okay. Let's do, we'll do 2 more. Let's do, this is a tricky one. Let's do number 5. Look at number 5, you guys. You've got 6,051. That 0 counts as a significant figure because it's in between 2 significants. And then these 2 zeros are after a decimal. And there's no other numbers over there, so they also count as significant digits. Isn't that tricky? Yeah. So how many have you got? 1, 2, 3, 4, 5, 6. This one has 6 sig figs. Okay. And we'll do one more. This number 6 is like number 1, so I won't do that one. And actually number 2 is a kind of a combination one. I don't know. I think number 8 is really easy. Number 8 and number 3 are like each other. So I kind of don't want to do it. I'll do number 7 because that one's a little tricky. Number 7 and number 2 are like each other. They're very similar to each other. So we will do number 7. So if you look at number 7, you have a 0 to the left. Again, that one to the left of the decimal never counts as a sig fig. The 1 is significant. The 2 is significant. That 0 in between them is significant. Because remember, when it's between, it always counts. And then you have that 0 on the end. It's on the end. It's to the right. When you have a decimal, it counts. That means they measured out to that place. So how many do we have? 1, 2, 3, 4. Okay. So now you guys figure out the other ones for those. Okay. And last but not least, we have, we're going to do some multiplication, division, subtraction, and addition. We're going to do all 4 major operations using sig figs. And so before we do that, let's go ahead on the back again and talk about those last 2 rules that I didn't talk about just now. So we're going to talk about rule 6 and 7. Rule 6 is when you're adding and subtracting, you're going to round your answer to the least number of decimal places in any of the numbers. If you look at this example right here, guys, this one's got 5 digits. This one's got 3, except that one doesn't count. And this one has 5. So your answer, to the least number of decimal places in any of the numbers that make up. Okay, so we're going to go by decimal places. This one has 2 decimal places. This has 1, and this has 3. I'm sorry, this has 3. So your answer is going to have just 1 decimal place. That means when you add these 3 numbers, you're going to end up dropping off some of it. So you see, when this number right here, guys, that's me adding up these 3 numbers. Okay, and I'll do it right now on the calculator so you can see it. Every time it does it. Okay. So we're going to add 123.25 plus 46.0. I'm just going to put 46, guys, because you know it's the same thing. And then plus 86.257. 86.257 equals. So I get 255.507, okay? So you see this one has 3 decimal places, but if you go back to your 3 terms that you added up, this one only has 2, this one only has 1, and this has 3. So your answer is going to have 1. That means we're going to take this number and round it. And so 255.5, yes. Because this is a 0, then you do not round up. You stay on the 5. And you could argue, yeah, but Miss Curran, this is a 7, so that would make this a 1. Yeah, but you would still stay down on 5, wouldn't you? Wouldn't you? Yeah, it's going to be... You would still stay on 5. You would not round up, okay? Just because the 7 can go up for that other number doesn't mean it's going to change the 5. It has to be the number right to the right of the 5 for it to make the 5 go up, okay? So back to where we were. Where were we? Yeah. So the 255.507 becomes 255.5, okay? And then when you're multiplying and dividing, you do the same thing. You look at the factors that you're multiplying or dividing, and again, you see how many digits. This one has 3, this one has 3, this one has 2. So your answer's only going to have 2, okay? So let's go to the other side and do that. And again, we have 4 problems. I'm not going to do all 4 of these. Which one's easier? I'm trying to decide. Beside the division and the multiplication. Well, actually, neither one of them is hard. So let's do the division one. So we've got 1035 divided by 42. 1035 divided by 42. And we get, I'm going to write the full number, 24.642857, etc., etc. Okay. This is not the final answer, you guys, because we've got to limit the sig figs, okay? For multiplication, let's go back on the back and check again what they said about multiplication. You limit and round to the least number of sig figs in any of the factors, okay? This one has 2 sig figs. This one has 3. This one has 2. So the answer for this one, we had to round this one to 2 sig figs, okay? See the 2 sig figs and the rest are zeros, okay? So let's look over here, the one we were just doing. Oh, I said I was going to divide, and then I put it in the multiplication place. Oops, let me write that number again, guys. I put it in the wrong place. You probably noticed that already, and you're like trying to yell at me, and I can't help you because I can't hear you. Let's try that again. 1035 divided by 42. 1035. Hey, what time is it? It's like after 9. It's after my bedtime. Divided by 42. And I'm going to put the number in the correct place. 24.6428. That's enough digits. Okay. So guys, look at the 2 terms we have. One of them has 4 digits. One has 2. Our answer is going to only have 2 because this one has 2. So look at this 24.64. We got to get rid of all of these. So are we just going to leave it as 24? No, we have to round up. You see how the number to the right of the 4 is a 6? If it's 5 or higher, you go up. So we're going to go up to 25. So the correct answer for that one is 25. Okay. And then here we've got subtraction and addition. The subtraction one is really easy. So I'll do the addition one with you. Okay, so this one's got 2 digits, this one's got 3, this one's got 4. The answer is going to have 2. See that? So let's go ahead and add these. 0.15 plus 1.15. Oh, you guys can't see the calculator. Let me put it where you can see it. This is in the way. It's so annoying. Okay. Okay. So I've got 0.15 and then 1.15 and then 2.051. Okay. And I get 3.351 as the answer. But we have to check our digits again. So remember we said because this one only has 2, the answer can only have 2 digits. Well, we've got 4 digits here, guys. So we have to get rid of these 2. So is it just 3.3? No, you have to look at to the right of that second number. You have to look and see if it's 5 or higher. What do we do with that 3? We go up. So the answer is going to be 3.4 for that one. Okay? All right. So hopefully that's enough information for you to use to go ahead and complete this sheet. As I mentioned, your test is going to have, this test on chapters 1 and 3 is going to have scientific notation. It's going to have significant figures. We're going to have to do conversions from one kind of unit to another unit like you did in your lab this week. And also temperature conversions and density calculations. So there's a good amount of math. I'll have calculators for you guys to use, but we need to do these practice sheets. You need to make sure that you get this completed before the test, so you've got to practice. I will let you use this during part of the test because there are more math type questions on this. I will be letting you guys have more time with your notes this time than we did last time. Okay, have a good one, folks.